So Dr. Owens, when you're looking at brain scans to determine if someone has damage, is this the type of damage that you're looking at on a microscopic level?
Yes, I use this slide actually in some of my lectures in the past. It's from the internet. What it's trying to show you, let's see if this pointer will work. All right, that thing right there is a brain cell. You have millions and millions of brain cells sitting up here. In order to communicate with another brain cell, it's got this thing called a dendrite or an axon that comes out. So if it's sitting right here and it wants to communicate with something over here, it's going to have to go along, it's going to send a little impulse along here, and typically it'll hit another neuron and it'll go all the way over to where it needs to go. That allows me to move my arm because something right here is telling my arm, hey, you can move and do that kind of stuff. It's more complicated than that, but that's in essence what's going on. What happens in what they call shear or post-concussion syndrome is if your brain is sitting in this hard skull, your brain is like kind of funny jello. And so if your skull hits something and stops, your skull's smart enough to stop, but your brain keeps going and it kind of wallops up against that skull. And you can have a bruise of your brain. And what happens is these little long neurons, they get twisted and they get torn. Sometimes they tear completely apart, but a lot of times what happens is the blood vessels that supply all these things, they're the weakest link and they get torn. And so you have what's called shear injury. And sometimes the cell completely dies and sometimes the cell just doesn't function very well. And
so when you talk about this damage, is it something that person can actually feel happening to them?
It all depends. I mean, if you've ever had a concussion, you're stunned, and a lot of times people report headaches and problems like that. But whether that's really probably not the actual shearing, because the shearing only takes a second or so. That's when your brain gets deformed. So you might feel the sequelae of it with headaches and things like that, but I'm not sure you actually feel this tearing because it's so quick.
Can you look at a person with the naked eye and tell that they've experienced this shearing in the brain?
Me personally, no. Clinicians do specialized tests, and from that a lot of times they can tell if somebody's had brain injury. But to just look at you, no.
So if these injuries can be seen at all, then can these brain scans, such as a CT scan or an MRI scan or a DTI scan, show this type of damage?
All right. There are two kinds of brain injury that you got. A major, which is real easy, because if you're out on 285 and you get into a big accident with a 18-wheeler and you hit your head and whatever, or you're 30 feet up on scaffolding and you fall and you hit your head, when you go to the hospital, along with all the other injuries you have to your body, more than likely you're going to have bleeding into your brain. That's major traumatic brain injury. And that's easy for us to detect. We see it about 100% of the time when we do a CT or an MR. The other side of it is called minor traumatic brain injury, and minor really doesn't do it justice, but minor is where you have all this shearing and stuff, but only about 10, maybe 12% of the time is the CT scan, the CAT scan positive, or the MR scan positive. So that's kind of why we do some of our other imaging, the DTI imaging that we're going to talk about, and the neuroquant and things like that.
And you talk about the CT scan. What exactly is a CT scan?
Everybody knows what a chest X-ray is. A CT is a specialized X-ray. So we're throwing X-rays through you, but instead of just going once right through your chest and catching it on some square-looking cassette, we do it in a circle. And we do it in a circle because we've got X-ray going here and a detector right there. So as we go around in a circle, we know how dense things are. So it's a specialized X-ray. It's very good at showing things like blood or big tumors, not very good at showing subtle things with neurons.
So if a CT scan comes back negative, does that mean there's no traumatic brain injury?
No, and like we said, only about 10, 12% of the time is a CT going to be positive when you've got what we would call minor traumatic brain injury.
So even if these CT scans don't show the traumatic brain injury, then why would the ER give somebody like Mr. LaGuerre the CT scan anyway?
Because it changes the equation. If you have bleeding in your brain, you're going straight up to the ICU. And they may even have to call a neurosurgeon and whatever else. If you don't have bleeding, then that makes them feel a whole lot better about how you're going to do in the next 24 hours. More than likely, you're not going to stop breathing or have a major event because you don't have big-time blood up there.
So is it normal for an ER doctor to discharge a patient who has a negative CT scan that same day?
I'm not an ER doc, but if everything else computed and they said, we think the guy's stable, a lot of times they will send him home.
Is it something you see in your practice where somebody may not be diagnosed with